Hey guys, Mr. T here, just doing another video on dividing by radicals. So fractions involving a radical, such as this, 5 on root 2 and 9 on root 3 minus root 5, involve dividing by a radical, obviously. So in mathematics, it's accepted that we rewrite numbers like this without the radical in the denominator, so nothing like this on the bottom. So for any fraction in the form b on root a, remove the radical by multiplying by root a on root a, which, if you divide the same thing by itself, which is going to be 1. So that's why we're allowed to do that. So in this case, your a is root 7, so we're going to times the numerator and the denominator by that. Root 7 on root 7, which is allowed because root 7 on root 7 is 1. So you're going to have 35 root 7 on root 7 times root 7, which is 7. 35 divided by 7 is actually 5. So your answer is 5 root 7. Now, sometimes the denominator is a bit more complex, such as this, 3 plus root 2. In this case, you need to multiply both the numerator and denominator, not just by a radical. You need to multiply it by the radical conjugate of the denominator. So 3 plus root 2 is the denominator. The radical conjugate of any expression, so in that form, a plus root b, which is what we had there, is going to be a minus root b. So you've just done the opposite sign between them. So the radical conjugate of 3 plus root 2 is going to be 3 minus root 2. Multiplying both the numerator and denominator by the conjugate of the denominator is allowed because this is the same as multiplying by 1. And the reason we do is because it actually gets rid of the radicals. This results in the denominator becoming a rational number, which is what is accepted in maths. So we've got a couple of examples here, right, with integer denominators. 5 on 3 take root 2. We need to multiply the numerator and denominator by the radical conjugate. So 3 plus root 2, 3 plus root 2. Why are we allowed to do this? Because that is 1. So you're going to have 5 lots of 3 plus root 2 on 3 minus root 2 times by 3 plus root 2. So what you'll have here is 5 times 3, which is 15, plus 5 root 2 over. This is a FOIL. 3 times by 3 plus 3 times by root 2 plus 3 times negative root 2 and negative root 2 times by root 2. And you'll see why we do the conjugate when we finish this FOIL. So 3 times by 3 is 9, plus outers 3 root 2, plus inners negative 3 root 2, and the last root 2 times, well, negative root 2 times by root 2 is going to be negative 2. And what you'll see here is these two terms cancel out because you've got 3 root 2 and minus 3 root 2. So you'll have no root 2's in the bottom. So you end up with 15 plus 5 root 2 on 9 take 2, which is 7. And that doesn't cancel down anymore. 7 doesn't go into 15, 5 doesn't go into 7. So that's the first one, showing why we multiply by the radical conjugate. So same here, 5 plus root 2, the conjugate is 5 minus root 2, 5 minus root 2. We're allowed to do this because this is technically 1. So 1 lot of 5 take root 2 on 5 plus root 2, 5 take root 2. I'm not going to show the steps of FOIL now because I've shown you that difference between two squares gets rid. That is a difference between two squares situation. Difference between two squares gets rid of those middle terms there. So you've got 5 take root 2 on 5 times 5 is 25. Root 2 times by negative root 2 is negative 2. You're going to have 5 take root 2 on 23. Alright, so that is a video on dividing by radicals. Hopefully that helps you out, and I'll see you in the next one.